The broadcast is now starting. All attendees are in listen-only mode.
All right, I'd like to welcome everyone back to another KevCAM night class tonight. Tonight have Steve Walsh helping out with any questions that come along for you guys. Steve, are you with us?
I am. Good evening, everyone. Thanks for attending.
And have also Greg Payton to help out to make sure I'm hitting all the key points for you guys and I'm not missing anything. Greg, are you there with us?
Good evening, everybody.
All right, so I do see quite a few new names in here, which is great to see. And so I'll just kind of go through quick housekeeping stuff with GoToWebinar in these night classes. Everybody is in mute just to eliminate any background noise. But if you guys do have any questions, there is a questions panel. Definitely type those in there. If you guys do have questions, very laid back class, solely dedicated for your guys' benefit. As well as this is something that we do every Tuesday night, and every night class is recorded. So if you guys would like to see a previous night class, you guys can go over to, let's see if I can get it pulled up, to the SolidCAM University, and you can see all the videos in here. So we have the night classes. Mark has been doing a great job of doing a SolidCAM Live, which is every day at 2 o'clock Eastern time, which is a quick little half hour, kind of ask your questions in there and we'll answer them live for you guys. So that option is there for you. But
Is there a way, if you were trying to get some information on maybe a certain topic, can you type in that topic and it'll pull up the content, or no?
Yeah, that's a great point. So in here, if you guys are on the channel, SolidCAM University, or type in KevCAM, you can come right here, and let's say we're looking at doing
fourth simultaneous.
What is it?
Fourth simultaneous, Kevin.
So if we just type in fourth axis, it's going to pull up anything to do with fourth axis for you guys. So we have basic setup, we have rotary machining, we have fourth and 5-axis drilling, 4-axis drilling, all kinds of fourth and fifth axis simultaneous. And this is actually a playlist of 23 different videos in here. So definitely come in here and check it out. And of course, everyone should have my email address, and if not, I will throw it in there right now. So I just put Steve's email address in there. Any technical questions, you can contact him.
Yeah, thank you very little.
No, I'm just kidding. My email address is in there. So for those of you guys who do have questions or looking for a specific video, definitely come here and check it out. I think between Greg, myself, and Mark, we have over 500 videos on how to do everything inside the software here. So all the way from adding a tool to sinking the snowmobile in the lake. So it's a one-stop shop for you guys.
I think it's nice, Kevin, because, you know, if you're working late at night or something comes up, your website's great. You can get instant information. I want to stress, though, obviously, our customers can call into tech support and talk to somebody live. But,
yeah.
You know, if you want to just maybe take a look at getting the content on your own, you can go here and type that in. Definitely, if you need support, certainly welcome to call into our help desk.
Yes.
So.
And Greg and I have gone through and made a playlist in here. So, and Mark, so there is a playlist set up for each little section. So if you guys are looking at Swiss, here is a complete how-to video on start to finish on how to do Swiss, or, you know, doing an introductory video or simultaneous. So this is where we've kind of gone through and really categorized everything for you to kind of help you guys out a little bit more, because like I said, there is a lot of content in here, so definitely come check it out. All right, with that being said, tonight we are going to be covering toolbox cycles. And the reason why I kind of want to do toolbox cycles is this is kind of one of those hidden gems that nobody knows about and they always kind of forget about, but there's a lot of neat features inside here that will really simplify your programming as well as your machining. So toolbox cycles is basically a is between a pocket operation. It's kind of a hybrid between a pocket operation and a profile operation to achieve certain different things. So tonight, what we'll be covering, well, let me just open it up here. And tonight, there are several different toolbox cycles in here. And we did this night class about 4 years ago. And we both Greg and I, we rushed through this as fast as we possibly could. But there's a lot of information in here. So what I'm going to do tonight is break this up into 4 sections. So tonight's class will be covering all this top half right here. And I'll show you guys examples to go along with all those. So first thing that we're going to start off with is a spiral open slot. And one thing I would like to stress to you guys is picking geometry. So picking geometry is no different, excuse me, is no different than picking profile or anything other, pocket or anything like that. But when we're grabbing our geometry, down here, you will see our picture that we have selected. So we're doing a spiral open slot. And what it's looking for geometry right now is the 2 lines. So I got the 1 line in my slot here, as well as the other line in my slot. So if I come in here, and if I just click on this face, we can grab our chains all automatically just by clicking on the face. And if you guys go to click on your face and nothing is selected, there is the smart face recognition down right here. So if you guys go to grab those faces and it's not grabbing anything, go ahead and turn that smart face on. By there, we have our geometry that it's looking for. So right now we are just going to be doing a standard slot, but we're going to be doing this in a circular pattern. So I have my geometry all selected here. We'll go ahead and grab a tool. And for this particular cut, I'll use a 1/2" end mill. As well, here's all your feeds and speeds. You'll notice right now I have my spindle RPM set to 1. This is by default. So if I forget to put a RPM in there and I go down to the machine and that spindle turns on to 1 RPM, I know something, I forgot to add a spindle RPM in there. So you guys can set these up as default as well. Now our levels, it automatically grabbed your levels for us, but what I'm going to do to make it fully associative is click on the bottom level there. And by this turning green, it is fully associative. So if this slot was to change in depth for us, this number would automatically update right here. Now, technology is kind of where the guts of everything are at. So starting at the top, how much do we want to take per pass? So on this particular part right here, we'll say that we're cutting aluminum. We can take it in full depth of cut. Now, with our spiral angle of engagement, this kind of goes along the lines with iMachining. So right now, I am telling it that I would like to do a minimum cutting angle of 40 degrees with a maximum angle of 60 degrees. So we're not going to, the nice thing with this is we're not going to over-engage our end mill. And what I mean by over-engage is like when we get into a corner with doing any kind of machining, that end mill gets into the corner, we're actually engaging that end mill at 180 degrees angle of engagement. So this will reduce that to give us much longer tool life. Now our retract distance is basically as it does an arc in, how much do we want that tool to lift up to go back over to the other side? So we can set that to 10 thou. iMachining is set to 3 thou, but you guys can have the full customization of changing that value right there. Yeah. Now we can do a wall offset as well as the floor offset, and we can tell it that we would like to finish the wall. So we can do a wall finish, and we can turn our compensation on. And let's say this slot right here has a very tight tolerance, so we'll just do 2 thou. Now our motion control, All of these toolbox cycles is just going to be more focused on picking your geometry, picking your tool, levels, and technology. There's 99% of the time you guys will not have to go past that. Motion control is going to be kind of more your fourth axis work, as well as your interpolation, and then your miscellaneous parameters of something that has been supplied by your post processor with your post guy. So in here we could do like an M00 stop. We could put some messages in there, but for right now, we'll go ahead and do a save and calculate. So looking at our toolpath here, I'm going to zoom in here. What we're doing is kind of like an iMachining toolpath in a way. So we're doing nice little morphing spirals, working our way through the entire slot. Okay. Now, like I said, if we wanted to change that up a little bit, maybe, you know, we want to do a minimum cut angle of 10 degrees and a max angle of 40 for running some titanium or something like that, we can change those parameters all right inside here. Okay. So now, if we want to run aluminum, something that can be much more aggressive, we can do like a 60 and 80 degrees. So you guys still have full control over everything that's going on here, but we're extending our tool life because typically when we would come in here, we'd do a slot, we'd be fully engaged for that first initial cut coming through. Okay? And then as we're coming back, it would be a partial engagement, where now we're doing that nice morphing spiral, working our way all the way through that part. Now, if we're, like I was saying, if we're running in harder material, and I didn't want to do it all in one cut, and get a side view here for you, I can come over here and change my step down to something smaller. And now you can see that we're taking this in 3 passes. So our first pass is taking the 100th thou, second pass is taking the 100th thou, and our last pass is going to clean up that additional material that is left over in there. So any questions on the spiral open pocket? Don't see anything coming through yet, so we'll go ahead and hop over to our next one here.
Kev, really, while you're pulling that up, the toolbox cycles for standard machining type applications, it's really a quicker jumping off point, right? It takes some of the, you know, guesswork out of it, if you will.
Yeah. What the toolbox cycles are really geared for is a very simplified operation for you as the user. So, you know, right now when I grab that geometry, all I had to do is grab the 2 geometry lines and tell it how much to cut. And I basically had a good tool path that is going to be set up for long tool life as well as really quick cycle times. So like I said, it's kind of a hybrid between a pocket operation, between a profile operation, as well as a little bit of iMachining mixed in there for you guys to really simplify it to your custom satisfaction.
Cool.
So let's do this one right here. Now this one is going to be pretty close to the same lines here, but we'll have a little bit more control on this one. So we have our same part size, and I forgot to show you guys that before, but we have 5" by 5" here. But with this slot, we have a very wide slot, which is 4 inches wide. So for this particular one, we can do, if we want to do that same tool path, we can do a spiral open slot, but there is one custom made just for doing an extra wide one. So grabbing our geometry like we did before. And we'll go ahead and grab that same tool here. Levels, and set our level. We're at 1/4 inch. Now, one thing that has been added from the previous one is our molding width, or our morphing spiral, as well as our parallel cuts. So our molding width is how wide do you want it to do the morphing spiral. And I like to really kind of get this as wide as possible in here just because I don't want to over-engage that end mill at any one point in time. So I'm just going to do a quick save and calculate here. And you can see here, we have very small molding or morphing spiral that is going on right in the center here. But that's going to take a little bit more time there. So what I can do now is, since my pocket is at 4 inches, I can open that up to something larger. So if we do like 3.5 inches, you'll see that I'm coming in here and doing this morphing spiral, taking these nice light cuts in there as it gets all the way through the part. And then when it gets to the end, I can do a nice parallel pass right in here. So if you have a really tight tolerance for your slot width, this is another great feature in here because I can tell it, all right, my step over for my parallel cuts or my semi-finish is set up at 125. And then as well as I can do a finished wall offset with a offset like 5 thou. So it's going to do the parallel cuts, leaving 5 thou on the wall to do one finish pass to finish off that wall for that tight tolerance. As well as we can run compensation also. And if we are looking for a really tight tolerance on that floor thickness, we can set up, excuse me, we can set up a floor finish also. So if I go and save and calculate this here, you can see that we're doing our morphing spiral at the 3.5 inches. And then I told it that I would like to do a straight line pass right here of 125 thou, leaving 5 thou on that wall to do one nice finish pass in there. So to do the, kind of to Steve's point, to do this exact operation right here, we would have to actually break this up into 3 different operations. So our first operation would be an eye machining to get this material, the center out. And then we would have to come back with a profile operation to clean up those outside edges for a high tolerance, as well as come back with a pocket operation to get that nice floor finish. So now, instead of doing this in 3 operations, we are able to do this all in 1 operation. And that's kind
really
of cool.
Trying to make easier programming, Kevin, right?
Yeah, absolutely. I mean, that's kind of the whole point behind all this is it's a simplified toolbox cycle that is very specific for what you guys are looking to do. And that's why they kind of call it the toolbox cycles, is because you have a whole toolbox full of all these custom operations in here to really get it geared towards the exact geometry that you're looking for. Okay.
Perfect.
So now what we'll hop over to do is we'll do a spiral pocket that is closed and kind of show you the difference there. So this pocket we just have the one open side and we have a closed chain on the other side. So we'll go ahead and do our toolbox cycle here.
Standard tool path, Kev, you'd have to be telling the software or anybody's software which side is open, which is closed, right?
Correct.
Yeah.
Yep.
Good.
And now for this specific geometry here, we are looking, it's telling us to chain just the slot as well as the closed area. So just by clicking on the face, it knows that it's not going to grab this chain over here because it's not looking for that chain. It's just looking for our straight line, our arc, as well as our straight line. So we'll go ahead and grab our tool here. Our profile depth. Now, you'll see that we are seeing very similar to what we were seeing with the large open slot. And if we go ahead and do a save and calculate here, I got lots of control of this toolpath here. So maybe on this particular one, I can take it all in one depth. So let's put this, what is our levels? 1/2 inch, oops. So I can come over here and set this right to 1/2 inch. So we're taking it all in one cut now. As well as, like I said, we're running a really tight morphine spiral in there. And our open slot is set to 3 inches. So we can set our molding width to 2.5. And now you can see we're doing our morphine spiral, working our way all the way through to the end, and it's automatically accommodating for that close pocket or our radius down here. And then it's going to come back and do its finishing passes or its parallel cuts. So if we only want to do maybe one parallel cut, we can change our molding width to 2.8. And now
it should be noted that as you increase that molding width, your runtime is going to be increased as well. So if speed's of the essence, you may want to keep that mold width down.
Yeah, yep, great point. So now we're telling it we're doing a minimum cutting angle of 40 degrees. And like I said, if we're running this in aluminum, we can definitely crank that up to something larger. So if we did a 60 and 80 degree, I really don't like going over 80 degrees. That way we're not over engaging our end mill at any one point in time. With all the iMachine research that they have done, we kind of found out that 80 degrees is kind of the max, or that sweet spot that we want to go. So as it's coming in there, doing the nice morphing spiral, and then coming back and taking those nice parallel passes to get that nice wall finish in there. Or if we want, we can set up our wall finish, and we could put a 2-thou wall finish in there. We can also do step downs in there. So if we're going really high tolerance, we could do like 100-thou step downs. So now it's going to do the morphing spiral, working its way around. But then when it comes to do its finish passes, you can see that we're taking our 100-thou step downs in there. So pretty neat stuff.
Kev, stupid question, but it wouldn't have to be a perfectly U-shaped type pocket either.
No.
Of course.
This is just basically, think of a pocket that is semi-opened. So what I mean by semi-open here is we have one open edge over here and then coming in there. Now, kind of leading off to our next one is, let's say we had a slot that is not open at all, and we wanted to attack that. So a completely closed slot, and I'll hop over to that one real quick. And this is kind of one of my favorites of the toolbox cycles in here. So now we have a completely closed slot. As we know, doing slots with end mills are definitely tough on our end mills, because usually we're engaging our end mills by 180 degrees. But if we do the toolbox cycle with just a little bit smaller of an end mill here, so it's looking for I messed up here. I got to pick my additional zigzag. So now it's looking to chain the entire slot. So I can just grab that face. We'll go ahead and grab our tool. And this particular one here, get this moved out of the way, is a radius of 1/2 inch. So I got a 1/4 inch end mill, something significantly smaller. How deep do we want to go? Now, a ramping width is basically how much do you want it to go back and forth to ramp into that cut. So let me just kind of save and calculate here. So right now, we are telling it that we would like to do a ramping width of 0.5. So from the start point right here to the end point is going to be that 1/2 inch. Now, where it comes over to the parallel cuts is, if we get a straight down view, here is our parallel cuts. How much do we want it to step over each time? As well as you guys have full control of how much you would like to take per pass. So maybe on this one, I would like it to zigzag the entire part width. So we have a 3 point, we can just do a 3.25 here. And now you will see it's starting over here doing a large ramp coming down to that 125. Now, if I put this at 0, it's going to go all the way down to the full bottom, or the full depth. So we're starting over here, doing a helix ramp, going down, doing a nice zigzag pattern going down all the way down to the bottom. And then once it hits the bottom, it's going to start its parallel passes, working its way around. So this, from what I have ran in the past, you will see a much better tool life doing it this way, as well as cycle time, because normally when we would do this, we would have to set this up as a profile and then do a clear offset to offset it into the center and do a contour pass working its way around. Or we would have to do this as a pocket operation and tell it that we would like to do the ramp coming in there and do its passes coming around as well. So, you know, kind of going back to like what Steve was talking about, these are kind of custom toolbox cycles per the application that you guys are looking to do it for here.
It can be really beneficial for a new user too, Kevin, right?
Yes.
Because there's
yes,
a lot
absolutely.
that would go into this, and
yep.
Yeah, if
this really takes the guesswork out for especially a new
yeah.
user.
Yep.
I mean, even for, you know, for Greg and myself to be able to come in and recreate this tool path, is we're going to have to do some, you know, some changing. You know, if we do this as a pocket operation, we're going to have to go through and select and deselect a bunch of features to get this looking exactly the way that we're trying to achieve. So this really simplifies things for you guys, and that's kind of exactly what the toolbox cycles are set up for, is a very simplified operation, but it gets you the results that you are exactly looking for.
Well, and toolbox cycles grow every year, Kevin, and I'm going to just throw this out there. I think a lot of them came from customer suggestions,
yes.
if I'm not mistaken.
Yep.
So,
yep.
You know, if you guys are running across features that, you know, are kind of typical and a toolbox cycle would help you out, we'd love to hear it. We can't promise it would get put into the software, but we're always open to ideas and suggestions to, you know, make that toolbox cycles more robust.
Yep, so, absolutely. Because SolidCAM, you know, their title is Leaders in Integrated CAM, but I like to say it as customer-driven CAM software.
Yeah, exactly. So,
all right, we do have one more for tonight, and I'll get that one open here. So this is a very simplified slot. So if we are able to take this all in one cut, it is a very simple slot. So I'm not looking to do any morphing in there. I'm just looking at doing a slot in here. Now, kind of go back to what we were just talking about. This can be done in a profile operation, but what it's doing in here is really simplifying everything for you. So we'll come over here, and we'll go ahead and grab our geometry, and I'm just going to select on that face. It's going to find my geometry that I'm looking for. Go ahead and grab our tool here, and just use our 1/2 inch end mill. Levels, I can just click on there, and very simplified. How much do I want to step down per pass, and do I want to do a finish on my wall and a finish on my floor? Is, like I said, very simplified, takes out a lot of that guesswork and is basic and simple as it comes. If you guys are doing a slot and you just want an end mill to kind of come in there, go around and come back out, this is where it kind of comes into factor. I don't have to worry about a lead in. I don't have to worry about lead out, because if I zoom in here, it's automatically adding that lead in and lead out for us. If we have a very high tolerance width, I can set up a small wall offset, and I can tell it that I would like to finish the wall doing a specific step down or take it all in one cut. I can turn my compensation on for my rough passes as well as for my finishing. Now if I zoom in here, you can see here's our rough pass that we're doing, as well as our finish pass to clean up that additional tooth all that's there. Now, if I'm looking at doing a slot that I want more of a roll in, so if we're doing like titanium or anything like that, what I can do, let me expand this out here. And I want to slowly engage into that material, I can do the roll in. Grab our geometry real quick. And grab that same end mill here. Our levels. And you can see I have a nice large roll in, so it's slowly rolling into that cutting right on center. So this is if we're just doing a open slot and we're just kind of coming in there full on size. We can do our step downs. We can switch up our approach distance right here. So if we wanted something that's considered to be larger, we can set that up so it's doing a straight coming in, and then it's slowly arcing into the material. As well as on the back side, if I need to go more than 10%, I can put maybe 100% of my tool in there. And you'll see that it automatically added that additional tool path in there for us. And if we don't want to go off of tool percentage, we can actually type in a value there as well. And that is it for part one. As you guys can see, there's a lot inside these toolbox cycles. And like I said, these are basically tools to really simplify things of what's going on. So if we had to recreate this operation, and I can just show you real quick with the profile operation. So we'll do save and calculate here. So if we were to recreate this in a profile operation, and this kind of goes to show kind of to Steve's point of the work that kind of goes into this, I would have to do a profile operation. And I have to grab that chain right there. Go ahead and grab that tool. Levels and technology. Now what I would have to do is come over to my geometry section. I would have to choose the take half of selected. And we will reverse this. And then we're taking it all in one pass, kind of like what we did before. And then I would have to come to my link and do a arc in as well as an arc out. And I can see that my arc in is actually kind of plunging right on top of the material right now. So I have to kind of play with my radius, and maybe if we did 10%, do the same as lead out here. So that's still not what I'm looking for. So you can see that takes a little bit of playing in here, where before I would not have to do this. Yeah, see,
Toolbox cycles can be your friend, Kevin, right?
Yes, absolutely. As you can see right now, I'm still suffering a little bit of what we're doing here. There we go. So now you can see after kind of playing with my lead in and lead out, I also had to come in here and switch up my technology to take half that cutter path. And now I have exactly what I'm looking for. So a lot less mouse clicks, a lot less thinking on my part, as well as, as you're linking here. So, and the linking can get a little bit confusing. So, like I said, with the toolbox, or what Steve was saying, the toolbox cycles is definitely your friend for these particular ones. Any questions from anybody?
Pretty quiet on the question front, Kevin.
I see that.
Yep.
Hopefully, I will kind of leave it at that. Now, next Tuesday night, we are going to still stay on the toolbox cycles, but what we'll be covering is the second half. So we will kind of be covering a closed slot, a spline slot, the temporary bridges, which is another one of my favorites, doing a corner to eliminate any air cutting, as well as broaching, and then rolling into a closed slot. So kind of the same thing as what we did here, but with a closed slot at that point. So that will be next week for everyone. Oh, we do have a question here. This is great. Never use toolbox cycles. Yeah. So we do have a comment from one of our guys here saying that, this is great, never use toolbox cycles. That is my whole goal for doing the night class on these toolbox cycles, because this is the one of the hidden gems inside SolidCAM that I feel on the support side of things that a lot of people overlook, is the toolbox cycles and how powerful it is inside here. So definitely come check it out. And then, like I said, next week we'll be covering all these features down here for you guys to kind of show you and give you some examples. If you guys would like these parts, definitely send me an email and I can send you off each one of these part files as well. So, but with that being said, I'd like to thank everyone for joining the night class tonight. Hopefully you got something out of it. I know a couple of the guys did because with the comments, but it's great seeing everyone in here, and hopefully everyone is staying safe and healthy out there. And my email address is in the chat for everyone. And then for anyone that is watching this on YouTube, it is in the comment section below. So if you guys do have questions on this or any other subject, definitely shoot me an email and we'll get those addressed right away. Steve, anything else you want to add before we end it off, or Greg?
No, all good from my chair, Kevin. Thanks.
Yep. Sounds good to me.
All right, guys. Well, have a great rest of your week. And if I don't talk to you in the meantime, we will talk to you guys next Tuesday night. Thanks, everyone.
Sounds good. See ya.